transformation of sin square t. Now we will discuss about the first shifting theorem in Laplace transformation. First of all, what is the first shifting theorem? We properly understand. Then we discuss about the examples of first shifting theorem. First, if the Laplace of ft is f bar s, here we know the Laplace of ft. Laplace of ft is f bar s, then Laplace of e raised to at ft. Here we multiply ft by at, then we get the new function of s, but it is similar to our original function of s, that means original Laplace. Now what is the change in this Laplace? So if Laplace of ft is f bar s or phi of s, then just we replace s by s minus a in each and every terms. So Laplace of e raised to at ft is equal to f bar s, s is replaced by s minus a, then Laplace of e raised to at ft equal to phi of s minus a. Now here we change each and every formula of the Laplace transformation. So we know the Laplace of 1 is 1 by s, then Laplace of e raised to at into 1 becomes 1 by s, and s is replaced by s minus a. So new function Laplace of e raised to at into 1 is 1 upon s minus a. Similarly, Laplace of k is k by s, we know that, but after multiplying with e raised to at, it will be k by s, s is replaced by s minus a, then Laplace of e raised to at into k is k upon s minus a. Similarly, Laplace of b raised to t is 1 upon s minus log b, we know that, then Laplace of e raised to at into bt becomes 1 upon s minus b, s is replaced by s minus a, then finally answer of Laplace of this form, Laplace of e raised to bt into e raised to at equal to 1 upon s minus a minus log b. Similarly, Laplace of e raised to minus at into b raised to t is equal to 1 upon s plus a minus log b. Here we just replace s by s minus a when function multiply with e raised to at, and s by we replace s by s plus a when function is multiply with e raised to minus at in the first shifting property of the Laplace. Now we write the directly formula of cos hyperbolic, sin hyperbolic, and cos and sine. First of all, what is the Laplace of e raised to bt cos hyperbolic at? Here we know the Laplace of cos hyperbolic at, and it is multiplied with e raised to bt, then we get s minus b and s minus b square minus s square, because we know the Laplace of cos hyperbolic at is s upon s square minus a square, and we just replace s by s minus b in this formula. So we get this formula for the first shifting property of cos hyperbolic at. Similarly, in the sin hyperbolic at, we multiply sine hyperbolic at by e raised to minus bt, then we just replace s by s plus b everywhere in the formula. We know the Laplace of sine hyperbolic at is a upon s square minus a square, but in this case we multiply sine hyperbolic with exponential function e raised to minus bt, so our formula becomes a upon s plus b my whole square minus a square. Here we replace s by s plus b. That is the property of the first shifting property in the Laplace transformation. Now Laplace of e raised to minus bt into cos t is s plus b upon s plus b whole square plus a square, because here we know that Laplace of cos at is s upon s square plus a square, and cos at multiply with e raised to minus bt, so replace s by s plus b everywhere. So here s replaced by s plus b in the numerator, and in the denominator also s is replaced by s plus b. So our function becomes Laplace of e raised to minus bt into cos at becomes s plus b upon s plus b whole square plus a square. Similarly, Laplace of e raised to bt into sin at is equal to a upon s minus b whole square plus a square. In the last formula, as we know that Laplace of t raised to n is equal to gamma of n plus 1 upon s raised to n plus 1 if n is not an integer. If n is integer, then it will be n factorial upon s raised to n plus 1. Now, if we multiply with e raised to bt to a t raised to n, then Laplace s is replaced by s minus b in the Laplace of t raised to n. We can see here s is replaced by s plus b only in the Laplace of t raised to n. So that is the first shifting property. Now we will see some basic examples of first shifting property. Let us see Laplace of e raised to minus 3t cos 2t sin cos 3t sin 2t. Here in the first part we multiply the function with e raised to 3t. E raised to 3t, after multiplying e raised to 3t, we have to apply first shifting property or first shifting theorem in the example. First of all, what is the first shifting property? So just s is replaced by s plus 3 in the first shifting property, but we have to first of all find the Laplace of this function. Here function is cos 3t into sin 2t. So first of all find the Laplace of this between function cos 3t and sin 2t. So to find Laplace of cos 3t and sin 2t, first of all we have to apply 2cs formula, that is s minus s. So to apply 2cs formula, we multiply and divide by 2 function, then 1 by 2 into 2 cos 3t sin 2t, and s is replaced by s plus 3, which is our first shifting property. It is applicable at the last of example, but first of all our concentration is on find the Laplace of this portion. Now we can apply the formula 2cs, that is s minus s. So here 2 cos 3t into sin 2t will be cos 5t minus sin t. Here after applying the formula we get Laplace of sin 5t and Laplace of sin t. We are also apply here directly linear property of the Laplace, and this is our shifting property it will be applicable later. First of all, find the Laplace of sine 5t. Laplace of sine 5t is s 5 upon s square plus 25, and Laplace of sine t is 1 upon s square plus 1. After applying these two formulas, now we can ready to apply first shifting property because our Laplace is done. First of all, we take the common 1 by 2 and just replace s by s plus 3 everywhere. So here s is replaced by s plus 3 and here also s is replaced by s plus 3. So finally our answer of Laplace of e raised to minus 3t cos 3t into sin 2t is equal to 1 by 2 5 upon s plus 3 whole square plus 25 minus 1 upon s plus 3 whole square plus 1. And after simplifying properly and expanding the brackets, we get final answer as 2 upon 2 into s square plus 6s plus 8 upon s square plus 6s plus 34 and into s square plus 6s plus 10. So here we can apply the first shifting property when our function is multiplied with e raised to at or e raised to minus bt or any other exponential function. Let us see one more example of the Laplace transfer first shifting property. Here find the Laplace of e raised to 2t into cos 3t. So here e raised to 2t multiply with cos cube t. First of all, we will find Laplace of cos cube t and then we apply the first shifting property. S is replaced by s minus 2, but our concentration on the find the Laplace of cos cube t. So we can't find the Laplace of cos cube t directly, but we first convert into the formula of cos cube t. Cos cube t equal to 1 by 4 cos 3 cos t plus cos 3t. After applying the formula of cos cube t, we can easily find the Laplace of cos t and cos 3t. So now after applying and taking the 1 by 4 common, we get find the Laplace of 3 cos t and Laplace of cos 3t. Now we know the Laplace of cos 3t. Here Laplace of cos 3t is s upon s square plus 1 and Laplace of cos 3t is s upon s square plus 9. So we are applying the directly Laplace of cos 3t and cos t. Now we apply the first shifting property s replaced by s minus 2 everywhere. Here we have a s in numerator, so we replace s by s minus 2 in the numerator and denominator both. So we get 3 by 4 into s minus 2 upon s minus 2 whole square plus 1 and plus 1 by 4 s minus 2 and upon s minus 2 whole square plus 9. So finally we get the Laplace of e raised to 2t cos cube t is equal to 1 by 4 3s minus 2 upon s minus 2 whole square plus 1 plus s minus 2 upon s minus 2 whole square plus 9. So these are the some examples related to first shifting property. Next topics of Laplace transformation we will see in the next lecture. Thank you very much.